So we're going to cover the stuff for your signature assignment or your core project, whatever you want to call it, for college algebra. You can find this in Canvas. It's been up there for quite a while, actually. So, but you can download it. It's 2 pages long. So the page number 1 is going to be very important for you. And page number 2 tells you the rubric. It tells you how I'm going to grade it. So you can essentially go through here, make sure you meet all these requirements so that you know that essentially what grade you're going to get. When you do this, it's going to give you some instructions. You've got to write me 2 different paragraphs. Both of them are short. One of them is about 300 words. One of them is about 200 words. You need to find some reliable sources online. Wikipedia is not a reliable source. It does have reliable material, but anybody can upload anything. And so it's not necessarily, there's no accountability. I can upload a whole bunch of trash, and because there's no oversight, it may or may not be true. So find some reliable sources. And basically what you're doing is you're going to use the periodic table of elements, and which is what you learn about in chemistry. You need to pick an element that has a radioactive half-life that is greater than 1 year. So I would suggest you go to Google and just say, what is a radioactive element with a half-life bigger than 1 year? I'm going to give you an example of polonium. You may not use polonium. Why? Because I used polonium. So in this case, the radioactive half-life of polonium is 102 years. Okay? So what does this mean? You're told to use one of 2 formulas, and so I'm going to walk you through how to do this. Basically, this is your formula. It says N of T equals N sub O times E raised to the negative KT. I need to know what K is in this particular instance. Since I'm looking for a half-life, remember if it's sub O, that's how much you're starting with. Okay? So I am starting with 100% of something. So I'm going to say 100. Okay? I'm starting with 100% of something. I have E, which is a number, raised to the negative K, and then T is always measured in years. So that's why we want this to be greater than 1 year. It cannot equal 1 year. It needs to be bigger than 1 year. So in my case, it's going to be 102. Okay. Now I want the half-life of it. So what is half of 100%? Well, half of 100% is 50%. So all that's going to be different for you is going to be the 102. Because for polonium, the half-life is 100 years. Okay, what that means is that after 102 years, it only has half of the radiation that it did at the start. Okay, so every 102 years, it will decrease in radioactivity by 50%. Okay, so we want to solve for K because K is going to be the constant that's going to be different for everybody. So what I'm going to do is I'm going to start getting rid of stuff. So I'm going to divide both sides by 100. So if I divide both sides by 100, that means 50 over 100 is 0.5, which should make sense because it's the half-life. And then I have E to the negative K times 102. So just like we were doing with the logarithm stuff in sections 7.2, 7.3, 7.4, all that, I now need to get this K down. So do I want to work with a base of 0.5 or do I want to work with a base of E? Well, I know what a base of E is. It's the natural log. So I'm going to take the natural log of both sides. And now that I'm in log world, that allows me to grab this exponent and drop it out front as a coefficient. So I now have the natural log of 0.5 equals a negative K times 102 times, sorry, I have a cold, times the natural log of E. Okay? Well, what did we learn the natural log of E is? If your base and your argument match, that's the same thing as 1. So this now is the same thing as 1, and 1 times anything doesn't change what it is. And now I can get K by itself. So I'm going to divide both sides by 102. So divide both sides by 102. And then that'll give me the natural log of 0.5 over 102 equals a negative K. Well, I don't care what negative K is. I care what positive K is. So I'm going to multiply both sides by -1. So this is now negative, which makes that positive. Okay. So K equals this mess right here. When I put that in my calculator, I have a negative natural log of 0.5, and I'm going to divide that by 102. So when I divide that, I get 0.006796. So 0.006796. That is your K value. Okay, so what does this mean? This means when you find your radioactive substance, which will not be polonium, you will find the K value specific to that substance. So what you're going to do now is return back to the original problem, and you're going to say N of T equals E raised to the negative 0.006796 times T. Okay? And I'm not going to have a coefficient here. It's just going to be 1 because I started with 100% of whatever it is. Okay, so that's the hard part. The next part you've got to do is you found your substance, your radioactive element. You solved for K and you rewrote it. So now what you need to do is you've got to graph 10 data points. So when you graph these 10 data points, what you need to recognize is if you use a T of 0, zero times this mess is 0, and E to the 0, any number to the 0, is 1. So one of your data points is 0, 1. So if your time is 0 years, then your answer is 1, which means 100% of the radioactivity is in there. And here's where you want to get kind of clever, okay? My radioactivity was at 102 years for a half-life. Sorry. So I am going to double that. Whatever you have for a half-life, you need to double. So at 1 year, holy cow, I just screwed this up. At 102 years, okay, you're going to find out that this gives you 0.49999, whatever, okay? So if I put in a T value of 102 years, instead of having 100% of the radioactivity, how much do I have? I've got half of it, or 50%, okay? So what you want to do is grab 10 data points. So what's the next one I could do? I could say, well, 204. So what did I do? I doubled again, and then take half of this. So what is half of this going to be? So I've already filled this out on my calculator. Oops, sorry. Hang on, I pressed the wrong button. Hang on. All right, if I go to the table, what you should see, because I filled it in, this has a really bad glare. Hang on. Does that help? No, it doesn't. All right, hang on. Does this help? Ooh, there you go. All right, so what I did was I said it's 0 years, then I said 102, then I doubled it. Well, what is half of 50%? It's about 25%. So then I doubled my years again. What is half of 50%? Okay, so I screwed up there, actually. But you just want to get some data points, okay? So what is, hang on, light bulb. All right, so half of this is going to be at roughly 25%. So 24,998. Okay, and then the thing I had on my calculator, I started going off on messing with something else. So do another 102 years, because that's when it's going to chop in half again. So another 102 years is going to be 306. Okay, then what's half of this? Okay, so that's how you're going to find this. You can always substitute it in since you're probably using a scientific calculator. Just take e to the, and then take this exponent times whatever your half-life is. Okay, and then just pay attention to what pops out. You need 10 data points. Now, these are going to get awfully small, awfully fast. So I would grab some data points between 0 and the first half-life. So I would grab like a 20. 25. I don't care. As long as when you plot them, you can see what's happening. So if I plot 0, 1, well, at 0, I have a 1, okay? At 102, I have half of that. So you'll notice you need your scale to be pretty dang huge. So you need this 1 to be like way up here. So here's 0, 1. And then at 102 years, you're at half of that. Okay, at 204 years, you're at half of that. At 306 years, you're at half of that. And then you'll see this lovely little shape coming out. So your job, first of all, find a radioactive element with a half-life that is greater than 1 year. You may not use polonium. Follow the steps that I just gave you here. The only difference between what I did and what you're going to do is that your number for the half-life number of years will be different than mine. Okay? Then when you fill this in, that means that your number for K will be different than mine. It will be negative, but it will be different. Okay? And then follow the instructions from there. So you're going to have to tell me a little bit of history about your chosen element. If you're going to encounter your element, where does your element come from? Where does it go? All that kind of good stuff. Give me some observations. You're going to have a y-intercept. What does it mean when you have a y-intercept? What does it mean if your time is 0 years? How much radioactivity is there? So I just gave you an answer. Okay. So find some negative, positive impacts, all that kind of stuff. Now, what you are going to do when you turn this into me, and this is where I will become Krabby Clam, okay? Page 1 needs to be a title page. So I need to know the name of your element. I need to know your name. I need to know what semester it is. I need to know my name, okay? You must know your section number. So if you'll look, like some of you, which I'll get to that in a second. All right, so page number 1 is, so go into Word and type up a title page. Make sure it has your name, the semester, college algebra, which is math 13, 14, and then your section number, and then my name. Page 2 is going to be a copy of the instructions. So you're going to use this first page, not the second page. No, no, no. Only the first page. Okay, so copy of the instructions, not the second page. On page 3, I want a really big, pretty graph. Make it pretty. Okay, well marked. Page 4 and on is going to be your paragraphs and your citations. You can do your citations in either MLA or APA format and just look up online how to do that. Again, I don't care as long as you do it correctly. So once you have this, you need to import everything into Word. So page number 1 in Word is your title page. Page number 2 is going to be a picture with your cell phone of this document. Pull it into Word. Page number 3 is your graph. Page number 4 is the rest of that. Once you have everything in Word in the correct order, you need to hit Save As, and on File Type, scroll down to PDF, and it's going to change it into a PDF for me. And then what you need to do, and so help me, please follow instructions. You need to name it 1314, and then a space, not a dash, not a period, nothing. 1314 space, then your section number. It'll be one of these 4 things. Then a space, and then your last name with a capital letter, space, your first name with a capital letter. Okay? So don't do anything else. No other punctuation, no nothing. Because I'm fixing to get 100 of these things at the same time, and I just want to drag and drop them into the correct folder. Okay, so as long as you do all of that, then I don't see why you wouldn't make a 100 on this project. However, don't irritate me. Follow instructions. Make sure you name it correctly. Do not send me pictures. Do not send me a Word document. Don't send me a link, anything like that. Let me know if you have questions. And that is it.